Okay, so hello everyone. Today I wanted to show something that I have discovered, and I think that I may have solved again in a better way the illumination problem. And to anyone that doesn't know what the illumination problem is, it basically this problem was created. It's a mathematical problem. It was let's say created by Ernst Strauss in the 1950s. Sorry if I don't say the name correctly. And it said that in a closed room, where every single wall was made of mirrors, is it possible for a room that was created? Okay, sorry, let me fix this. I can make better shape. Is it possible for a light in a room to have a place where there was no light reflection? For example, here, if we think this as a light, it will create light and it will go all over the place. It will illuminate the entire polygon, in this case the rectangle. So the first way they solved it was with this shape. Sorry for the terrible drawing. With this shape, if you were to put a candle here, it will reach every single place. It will illuminate everything except for these places right here, these two angles. And if you place a candle right here, it won't illuminate these two places. So this was a very neat way, but this isn't a figure. It isn't. It's not like, for example, a rectangle or a square. It is not a polygon. So the second way it was solved was with this shape. Oops, let me remove this. I couldn't replicate it perfectly, but this is the best that I could do. So with this shape, in any way, anywhere you put a candle, if you put it like, for example, here. Let me open up a new thing. If you put the candle, I think it was around here, it is going to be, the entire room is going to be illuminated except for one really tiny infinitesimal point. For example, like this. So every single place will get illuminated except for this tiny, almost invisible dot. Of course, it is way smaller, but I cannot go too small with the pens that I have here because there is a size limit. Also, the page isn't too big, so this was an example of how it was solved with a polynomial, and polynomial with a polygon. But I found an even better way of doing it, and I will show you right now. If we take, for example, a rectangle, if I were to put a light here, hold on, you would think that it will reach every place. But the thing is, what changes is that I will give this a normal size, for example, of 2 meters. But I will give the two sides here an infinite value, a positive infinite value. So it tends towards infinity. So even this is positive infinity, and this is 2 meters again. So this light, it will never reach the end. So there will always be an infinite area. I mean, you can see it because, of course, it's a drawing. You cannot really represent infinity. It is like if we made something like this. Let me try to give you a small example. It's like if I made something like this, and I made the lights are here. See, like this, it would take a lot for it to go all the way there. But if it was actually infinite, as the way I created it here, it would mean that it would never reach the end. So there would be an infinite space in which it is not illuminated. And some may think, okay, then what if I put here and then I put it here, it's going to be kind of the same. I mean, I could technically illuminate it all. And I could understand this, even if it is not true, because it's still infinity. But if you really want to do something like that, we could create another, it's different, with another polygon with more than 4 sides. if we create it like this, okay, this is the, okay, not too good, but you get what I want to do. So we give this value, oops, I'm sorry, a positive infinity. Again, infinity, it is the same positive infinity, only because it should, a figure, it should start from 0. I don't want it to go into the negatives. So we give these two values infinite. This one can be any, I mean, we could give technically infinite to everything, but it would not result in a pretty thing. So we give this one, we cannot give this, we have to give this one infinite too, because it will make no sense for this to not be infinite. So we have to give infinite to this one too, infinite to this, and infinite to this. So see, this is the problem. This is why this one is so much better. But you could use this one too. So if I put a candle here, I'm never going to be able to illuminate the whole place. Same if I put a candle here or a candle here. Or even if I do this, if I put a candle here and a candle here, they will never illuminate this space, because there is an infinite space between them. So they are never going to be able to illuminate it. So this is the way to solve again in a better way this problem, because I used a polygon like this one. I didn't use a figure, not normal figure like this one. I used a polygon, and it didn't have 26 sides. It only had, look, only 4 sides, and they are 2 and 2. It's a simple rectangle. So I think that this is a better way to solve the illumination problem. And thank you for watching the video. I think I will stop in here. I made my point clear, and I hope you understand it. If you have any problems, just ask me, send me a message, or either on YouTube or anywhere else, any contact I have. And thank you for watching this video, everyone.